Good afternoon. In part 2 of this tutorial, I'm going to talk about what one needs to do to compensate for the diameter of the inkjet droplet. If you recall, we had a stencil, and the stencil had three different opening shapes: this circle, this narrow slot, and this larger slot. The most critical dimension would be the width of this slot, which we measured to be 0.079 millimeter. That's what we want to get onto our substrate. In order to process this, we would first convert it into Gerber, and the Gerber file would look like this. If we zoom in to measure this, we'll find that the distance is 0.079. So we haven't lost any information in our conversion from AutoCAD to Gerber. Now let's rasterize this. I've created a small batch file that loads my little test file, creates a no shrink bitmap, inverts it, and a DPI of 2500. And I've got a very small margin, so let's run this. So here's our bitmap, and at first look it looks okay, but we haven't taken into account the diameter of the droplet. And since the droplet is actually 45 microns and these little steps are 10 microns, you can see a 45 micron droplet on that edge pixel is going to leak quite a bit into the opening on each side, and we'll end up with a mask opening that's much narrower. Now I can actually visualize this by using Artwork's droplet simulator, which I'll run next. This program takes a bitmap, in this case my no shrink TIFF file, and it replaces every pixel with a flash of diameter that you specify, and I'm specifying to be 0.045 millimeter. And it creates a Gerber file which I can then view, and that'll show me the effect of my droplet diameter. So let's run this. When we look at the simulation without compensation, this appears a little narrow and this appears also a little small. Let's measure this. We use our ruler, there to there, and it's telling me it's only 0.56 when we start it with 0.79. Our opening is a lot narrower than we originally intended, and this might be such that the part is no longer good. We'd like to compensate for that problem by using the compensation in the Gerber rasterizer. I've got a different command line, and in this case I've changed the output name to comp with shrink, and I've added a new parameter called -shrink. You can see I've used -0.0225 millimeter. That's 1/2 of the droplet diameter, so that's what we're going to process. If I look at the with shrink bitmap, I see that these are a little wider than I expected, which is good because it's going to take into account the droplet diameter. So now let's run the droplet simulator on this file and see what our actual final opening is. So here's my droplet simulator, and this time I'm running the comp with shrink, and I'm putting out a comp with shrink droplet simulation. Here's my simulated look, and let's zoom in and measure this area. You can see that the distance is 0.096, and you might ask why we don't have the original 0.079. You have to remember that even though we're compensating for the droplet diameter, we can't actually compensate for the snapping due to the grid resolution. We have about 10 microns of grid resolution, and this particular opening must have snapped slightly wider. We could in fact have a 1 pixel variation, which would be unavoidable. We're a lot closer to what we wanted as a target than we were if we didn't do any droplet compensation. The moral of the story is that not only do you have to use droplet compensation, but you should also pick a DPI that's high enough that a single pixel snap won't cause your opening to be out of tolerance. Thank you.